Hi everyone. In this video I will be deriving the series expansion for e to the x. So we have the expansion of e to the x looking something like this. For any function f of x, the expansion will look like this. So particularly we're looking at e to the x. So we want to determine the coefficients for this expansion. So what we're going to do, if we want to get the first coefficient, a naught, which is by itself, it's not multiplied by x, how can we get rid of the other x terms to disappear? What we can do is we can simply plug in 0 for x. If we do that, we are left with all of these terms disappear, and we have e to the 0 is just 1. So a naught equals 1. So now what do we do for the other terms? We're going to take the derivative of e to the x. We know that the derivative of e to the x is just e to the x. So in this case, all those higher order terms are going to go down by, we're going to do the derivative of everything on the right side as well. So we are going to be left with this. We're going to be left with a1 plus 2 ax to a sub 2x plus 3 a sub 3x squared, and so on. So what we're going to do here, same thing as before, we're going to substitute in 0 for x. So then we are given, if we put 0 in for x, we get what a sub 1 equals. We get a sub 1 equals 1. If we do this again, we're going to have 2 a sub 2 plus 6. But another, probably an easier way to write it, do 3 times 2 a 3x. Because by doing this, it's going to help us to see a pattern. Solve for a sub 2. A sub 2 in this case, plugging 0 for x again, is just 1/2. We do a sub 3. We do that. We got 3 times 2 times 1. Well, that's 3 factorial. 2 times 1 is 2 factorial. Starting to see a pattern? So here, now we're isolating what would be the fourth term, or the a sub 3 term. We have e to the x equals 3 times 2 times 1 a sub 3 plus, if we kept our series going, we would have 4 times 3 times 2 a sub 4x as the next term, which looks a whole lot like each term is then being multiplied by the factorial. So then it's factorial. So then for the third term, we have 1 divided by 3 factorial equals a sub 3. If we do the same thing with a sub 4, we get a sub 4 is 1 over 4 factorial. So what we have here is we have developed a pattern for the coefficients for the expansion of e to the x. So if we plug those coefficients back in, we can see that the series expansion for ex is 1 plus x squared divided by 2 factorial plus x cubed divided by 3 factorial, and the other ones. So that is the series expansion of e to the x.